This lesson is over exponential applications. Example 1. Suppose Kayla invested $750 at 7% interest, compounded quarterly. How much would she have after 10 years? Well, first, let's look for a key phrase. Notice the phrase compounded quarterly. Well, automatically, because you see that phrase, we are going to use the compound interest formula of A equals P, parentheses, 1 plus R over N, close parentheses, raised to the power of NT. So that's going to be our plan, but what actually are we looking for? So go back and find the question. Notice it says, how much would she have after 10 years? Well, would that be the A, the P, the R, the N, or the T? Because it's asking for after 10 years, it's wanting the end amount, which means we are solving for A. A is going to represent the amount after 10 years. Now let's plug in the appropriate values into the equation. Do we know A? No, that's what we're looking for, so the A will remain. For P, that means the principal or beginning amount. Do we know that? Yes, notice she invested $750. We keep the 1 plus, and now we're ready for the fraction. R represents the interest rate, which we have 7%, but it must be written in decimal form, so we have 0.07. Next, we have N. Now, N will always be disguised as a word. In this case, the N will be quarterly, which means it has a hidden value of 4. Now, for the exponent, we have N times T. N is still going to be that hidden word, which we already said is quarterly, which means a 4 will take its place. For T, that means time. And we notice we are going to have the money invested for 10 years. So now that we have the values plugged into the equation, now we're ready to kind of simplify and solve it. So according to GEMS, we have to focus inside the parentheses first. And notice division comes before addition. So take the time now to do the division of 0.07 divided by 4. Hopefully you found the division to be 0.0175, and also the exponents 4 times 10 can be written now as 40. Now we're still doing GEMS. Notice in the parentheses we have 1 plus this decimal value, and we can go ahead and combine those. When we do, our equation is now A equals 750, parentheses, 1.0175, close parentheses, raised to a power of 40. From here, we're ready to pick up our calculator and type this all in. Hopefully you found the result to be A equals 1,501.198007. Now, although that is correct, and nowhere in this problem did it ask us to round, but you have to think what you're trying to solve for. We're talking about money. Well, when we talk about money, we can only have 2 numbers past the decimal. So we have to round there. So we find the number that's 2 places to the right of the decimal and look immediately to the right to decide if we round up or stay the same. Since we have the number 8 beside the value, that means we will round up. So instead of being 19 cents, it now will be 20 cents. So A equals 1,501.20. So we've defined it, we had our equation, we've solved it, now we're ready to write our sentence. Kayla would have $1,501.20 after 10 years. Let's look at another example. Example 2. How much would your mom need to invest now at 8.5% compounded semi-annually to have $20,000 towards retirement in 10 years? First, let's see if we can find a key phrase. Hopefully you notice the key phrase of compounded semi-annually. Because we see that means automatically we are going to be using the compound interest formula, which is A equals P parentheses 1 plus R over N close parentheses raised to a power of N times T. Now that we know what we're going to be using, now we need to find what are we looking for. So see if you can find it in the question. How much would your mom need to invest now? Now notice that means invest right now, at the beginning. Well, look at your equation. To invest right now, would that be A, P, R, N, or T? Well, your initial investment is represented as your principal, which means it is going to be your letter P. So now that we know what we're looking for, let's plug in the correct values. A represents your ending amount. Well, notice she wants to have $20,000, so that takes the place of A. P is your initial investment. Notice that's what we're trying to find, so P will stay. We keep the 1 plus, and now we're ready to find our R value. R is your interest rate, which in this case is 8.5%. But we cannot keep it in percent form, we must change it to decimal, which becomes 0.085. Now in the denominator, we need to identify our N value. Recall, N is always going to be disguised as a word. In this case, that word happens to be semi-annually, which simply means twice a year. So 2 takes the place of N. In the exponent, we have N times T. Now N is still that semi-annual, which still represents a value of 2. And T, well, that stands for time. And we're looking at the retirement in 10 years, so 10 takes the place of T. Now this is our equation. Now we need to solve and simplify and find that hidden value of P. According to GEMS, we need to work inside the parentheses first. And again, we have to do the division before we do the addition. Take a moment now to do the division of 0.085 divided by 2. Hopefully you found the result to be 0.0425. And also the exponents 2 times 10 can now be written as 20. Again, look in the parentheses. We have a 1 plus this decimal value, which can be combined. So now we have 20,000 equals P, parentheses 1.0425 raised to the 20th power. Since we're trying to solve for P, notice what P is doing. It's touching the parenthesis. Since it's touching, that implies multiplication, which means to undo that, we need to divide the right side and the left side by 1.0425 raised to the 20th power. Now on the right side, any number divided by itself will reduce to 1, leaving us with P. But on the left side, you will need to use a calculator. Take the time now to do that. Hopefully you found the result to be 8,699.789063 equals P. But remember, we're talking about money, which means you can only keep 2 values past the decimal. So we look immediately to the right of the second value to see if we will round up or stay the same. Any values that are 5 or larger will round up. And in this case, it looks like we too will round up. So our result is 8,699.79. Now that we've solved it, we're ready for our sentence. My mom would need to invest $8,699.79 now. Now let's talk about population growth. Population growth could represent the population of people, population of bacteria, of money, of items. It just means there is a growth happening. Now it's represented by the equation P of t equals P naught E raised to the kt power, where k has to be greater than 0. Now, this is a new equation, so let's make sure we understand all of those parts. P of t means the population after a certain amount of time. Next, P naught. That basically is P with a sunken down 0. Simply means the beginning population when time equals 0. That's why it's P sub 0 or P naught. It just means that's the very beginning. Now E. E is its own value. Remember, E is that 2.718. So we never plug a value in for E because it is its own value. Now K is known as the exponential growth rate. Since it is a rate, it is usually represented by a percent. But when you plug it into the equation, again, it must be in decimal form. Like before, t will equal time. So now that we know the different parts, just so you know what this might look like, on a graph, a population growth is growing, which means it's an increase. So as you read it from left to right, it will be going up like an exponential function. Example 3. A population of rabbits has an exponential growth rate of 11.7% per day. Consider an initial population of 100 rabbits. Part A. Find the exponential growth function over time, t, in days. Part B. Using your function from Part A, estimate the population of rabbits after 2 weeks. Well, let's start with Part A. Notice the key phrase, exponential growth. Because it says exponential growth, that means automatically we are using that function of P of t equals P naught E raised to the kt power. Now find exponential growth function over time, t in days. That means I do want to keep this generic, meaning I do want to keep t as part of the function. It means your final answer is not going to be a number. Okay, so let's plug in the information we do know. Since I'm trying to find the function over t time, it means I will keep the notation P of t. That means I can look at the population at any moment in time. Now next, P naught or P sub 0 means my initial population. Do I know how many rabbits I started off with? Yes, the initial population was 100. Next, we have the E, which is its own value, so it will remain the same. Next, we have the power of K times T. K is your growth rate. Do we know our growth rate? Absolutely, 11.7% per day. Now we cannot keep it as a percent, we must change it to a decimal, which is 0.117. Next, we need to find T, which means time. But keep in mind, we want to keep the T floating around, so we keep the T, which helps us look at any moment in time. Well, congratulations. This is your function. P of t equals 100 E raised to the power of 0.117 t. Now looking at Part B, it says using your function from Part A, estimate the population of rabbits after 2 weeks. So what are we looking for again? Well, we're looking for the population after 2 weeks. So we're finding the end result. Now be careful. Notice it has a growth rate of 11.7% per day. We cannot keep it in terms of weeks. We have to know that 2 weeks really means 14 days. So we've defined our variable. We know the function, that's our equation. We're going to be using 100 times e raised to the power of 0.117 t. But because we're looking at a certain population in 14 days, that now means every time I see t, what value gets plugged in? Well, that would be 14. Now from here, I want to simplify. My exponent of 0.117 times 14 can be multiplied. And when you do, you now have an exponent of 1.638. From here, we're now ready to pick up a calculator. Type in 100 times e raised to the power of 1.638. And hopefully you found the result to be 514.4869477. Now, although we've done everything correct, keep in mind what we're talking about. This is not money. This time we're talking about rabbits, real animals, which means we're not going to round to two places past the decimal. Instead, we are going to round to the nearest whole number. So we look at the ones place, look immediately to the right. Because it's a value less than 4, that means we will not round up. Instead, it will stay the same, which means in 2 weeks there should be approximately 514 rabbits. So again, write that as a sentence. When interest is paid on interest, it is called compounded interest. If it is compounded continuously, we can still use the function p of t equals p naught e raised to the kt power to represent the growth of the account. Example 4. Imagine that you have invested $8,000 at 6.2% per year, compounded continuously. What is the balance after 5 years? Well, first look for any key phrases. Hopefully you notice the phrase compounded continuously. Because you see compounded continuously, that means that is going to be your exponential growth function. Instead of p of t, I'm now writing it as a of t, meaning the amount at a certain moment in time. So that means we are using that formula, but let's see, what exactly are we trying to solve for? So see if you can find the question. Well, it says, what is the balance after 5 years? Well, after 5 years, it means the end result, which means we are looking for a of t, which represents the amount after 5 years. Now that we know what we're solving for, let's plug in all the information. Do we know the a of t value? No, that's what we're trying to solve. Do we know the initial investment? Yes, it's $8,000. Do we plug anything in for E? No, E is its very own value. K, do we know the exponential growth rate? Well, we know the interest rate, which is the growth rate, 6.2%. But you must write it as a decimal, which is 0.062. Next, we need to identify the time. And notice we're looking for it in 5 years, so 5 is your t value. From here, we want to simplify the exponents. Notice 0.062 times 5 can be multiplied. And when you do, you should now have the equation 8,000 e raised to the power of 0.31. From here, there's nothing else we can do, so we now pick up the calculator and let it do the calculations for us. Take a moment now to do that. Hopefully you found the result to be 10,907.40091. Now keep in mind, this time we are talking about money, which means we need to pay attention to the number of decimals. We can only keep two values to the right, so we round appropriately. In this case, we will not round up. It will stay the same. So, after 5 years, the balance would be $10,907.40. Now, I have a question for you. How long would it take for your investment to double? Now notice, we're talking about for your investment to double. What does it mean to double? Well, double means 2 times something. Well, for us, is 2 times our investment. Recall, we invested $8,000. So for it to double, it must equal what? $16,000. Now that we understand that it would double to $16,000, the question is, how long is that going to take? Well, that means we're looking for a time. So in this case, T equals time to double the investment. Now again, we're still using the same function. The A of T equals P naught e to the KT power. And we're still talking about our investment with the same rate, but this time we're trying to see how long will it take to double. Well, A of T means the end amount. And for it to double, that means it would be 16,000. Your P naught is your initial investment, which we invested $8,000. Again, we keep the E. Our K was our growth rate or interest rate, which was 6.2%, but it has to be in decimal form. But this time, we don't know the time because that's what we're trying to find. So T remains as a power. Now this is our equation. Notice the variable we're trying to solve for is stuck up in space. It's trapped as an exponent, which means we need to slowly remove things away from it. Well, since it's trapped up in space, that exponent is linked to the E value. But what's immediately in front of the E? Well, that's the 8,000. The 8,000 is multiplying the E, so how do I undo multiplying by 8,000? Well, we divide. What you do on one side, you must do to the other side. And when you do, we get 2 equals E raised to the power of 0.062 t. So we've helped remove a little bit of numbers away from the variable, but our variable is still trapped as an exponent. So think back to all your rules and all your skills that you've learned over the semester. How do we get a variable out of the exponent? Well, because we have a base of E, we are going to take the natural log, as long as what you do to one side, you must do to the other side. So we're taking the natural log of both sides. Now remember, natural log runs off of base E. So on the right side, we have natural log base E of E raised to this power. Well, recall there's a unique relationship over there. It actually reduces to just the exponent. So our equation is now natural log of 2 equals 0.062 t. Congratulations, your number is no longer an exponent. So we're one step away from isolating and finding t. Our last step is to divide both sides by 0.062. So on your calculator, do natural log of 2 divided by 0.062, and let's see what you find. Hopefully you found t to equal 11.1797, but in this case, I want us to round to the nearest tenth, which means it will be t is approximately 11.2. So since we've defined it, have an equation, we've solved it, our sentence comes last. It will take approximately 11.2 years for the investment to double. Models of limited growth. Sometimes there are factors that prevent a population from exceeding some limiting value. Maybe it's food, space, air, Natural resources. Models of limited growth are represented by the equation P of t equals A all over 1 plus B times E raised to the power of negative kt. This equation is known as the logistic function. No worries, you do not have to memorize this formula, but I do want you to kind of understand it. It means that there is a limiting factor, a limiting population of something due to restrictions. Look at the room that you are in now. Could you possibly physically fit 1 million people in that room? No, because there's constraints. The walls, the ceilings, the floors, you are limited to a certain amount of space. And that's what this function does. Now, this function increases towards a limited value of A, meaning that's its max capacity. So graphically, it means there will be a horizontal asymptote at y equals A. Let's look at an example. Example 5. A lake is stocked with a fish of a new variety. The size of the lake, availability of food, and the number of other fish restrict the growth of that type of fish to a limiting value of 3,040. The population of fish in the lake after time t, in months, is given by the function P of t equals, and in the numerator we have 3,040 all over, and in the denominator we have 1 plus 3.75 e raised to the power of negative 0.32 t. Part A says, what is the beginning population of the new fish? And B says, what is the population after 5 months and after 20 months? First off, they did give us an equation, but we do need to define the variables. Notice inside the equation, inside the function, we have the letter t. What does t stand for? Well, it stands for time in months. And on the outside, we have P of t. What does P represent? Well, that means the population of the fish. Let's start with part A. Notice it's asking, what is the beginning population? That means we're solving for P of t, which means they somehow gave us a t value. But again, notice the phrase, beginning population. That means the very beginning, the initial, the start of it, which is code for t equals 0. Now, we've already defined we have the equation we're now trying to solve, which means in the equation, every time you see t, we plug in a value of 0. Once you have this in writing, now you may pick up your calculator and type this in. But you have to be very careful. In your calculator, you will type 3,040 divided by, but it's the denominator part that gets tricky in the calculator. Because we have more than one value in the denominator, you must use parentheses. Here is a visual as to what it might look like in your calculator. Notice the parentheses that encompasses and keeps the denominator all together. If you do not have those parentheses, your calculator will perform the calculations wrong. Hopefully you found the result to be 640. Now that we've solved it, let's write our sentence. The beginning population was 640 fish. Now looking at part B, what is the population after 5 months and after 20 months? So let's start with after 5 months. What does that mean to us? Well, they're telling us that's where t equals 5. So again, we've already defined it. We have the equation. Now we're on the solving step. So we plug a 5 into the function every time you see t. Now, just like before, you must use parentheses in the denominator when you type this in the calculator. Hopefully you find the result to be 1,730.11174. But keep in mind, these are fish, so we have to round to the nearest whole number. And so 0 is in the whole number's place. We look to the right, and notice we will not round up. So this time our result will be 1,730 fish. Since we've solved it, we are now ready for our sentence. After 5 months, the population will be 1,730 fish. Now let's talk about after 20 months. What does that mean for us? Well, that means where t equals 20. Again, we already have the equation, so every time you see t, this time you plug in a value of 20. Like before, make sure you include parentheses in the denominator. For the result, hopefully you found 3,021.175, and it continues. But again, we're talking about fish, so we must round to the nearest whole item, whole number, and in this case, that would be 3,021 fish. Since we've solved it, we're now ready for our sentence. After 20 months, the population was 3,021 fish. Exponential decay. This is the continual decrease in something, whether it's money, value, population, bacteria. Exponential decay is represented by the function p of t equals p naught e raised to the power of negative kt, where k is greater than 0. Now this function should look familiar, but it is slightly different. What is different about it? Notice it has a negative exponent. Now we are going to define what each of these variables represent. P of t represents the population after time t. P naught is the beginning population where t equals 0. K is now the decay rate, which will be represented as a percent, and t represents the time. Now visually, this will be a graph that decreases from left to right, and it's all because the exponent is negative. Example 6. The percent of adults who are married is decreasing continually since 1960. In 1960, 72.2% of adults were married. But in 2012, the percent fell to 50.5%. Now notice they've given us some information. They said in 1960, 72.2% of adults were married. They also told us that in 2012 that the percent fell to 50.5%. Notice this information. 1960 and 2012 are years, which are a measurement of time. And then the percentage, 72.2% and 50.5%, that is the percent of the population. So keep that in mind. Now part A asks, find the value of k rounded to 4 decimal places and write the exponential function that describes the percent of adults married after time t in years, where t is the number of years since 1960. Now, notice it's asking for the exponential function. That's reminding you that we are going to be using the function p of t equals p naught e raised to the kt power. So that's going to be our format, but we have to kind of sort this information. So in the formula, we have p of t, p naught, k, and t. All right, so starting from here, look at the information. In the past, 1960. In the question, it says where t is the number of years after 1960. So p naught is your starting year. Well, in 1960, what was the percent of the population? 72.2. Now, P of t represents the population after a certain amount of time. We know that years later, in the year 2012, we know the population was 50.5. Now K. Do we know K? Well, notice it says find the value of K, which means we do not know that value. Now for T. T represents time. They didn't tell us explicitly that this many years have passed or check at this moment in time, but they did give us some information. There is a difference in time between the years 2012 and 1960. If you subtract, you will find that that is 52 years. Now let's plug this information into the equation. For P of t, we put a 50.5, for P naught, 72.2, and then for t, we plug in a 52. So our equation is 50.5 equals 72.2 e raised to the power of k times 52. Now notice the variable we're trying to solve for is trapped as an exponent. So what we need to do is try to remove everything that is not trapped as an exponent to help us solve. And in this case, notice 72.2 is not touching the exponent. So to undo the multiplication, we will divide the right side and the left side by 72.2. When you type that in the calculator, the result will be 0.69944, and it does continue. But in the directions, it says round to 4 decimal places. Well, what we do is we keep 1 decimal place past that so that it will help us round towards the end. So I'm keeping 5 values past the decimal. Now, notice our variable is still trapped as an exponent, so we have to remember what tools and tricks can we use to get it out of the exponent? Well, that would be taking the log of both sides of the equation. In this case, because we have an e, we don't want to use the common log. Instead, we want to use the natural log of both sides. So we have the natural log of 0.69944 equals the natural log of base e of e raised to the power of 52k. Now remember, natural log runs off of base e, and it's taking it of e, which means it reduces and leaves you with just the exponent. So now we're one step away from getting k by itself. The last thing we need to do is divide the right side and the left side by 52. When you type that in the calculator, the result should be negative 0.00687. But the directions said round to 4 decimal places. So we look, we check, and we do need to round up in this case, which means k equals negative 0.0069. Now we're not done. Part A says find the value of k, which we've done, and write the exponential function, which means I need to find the generic function so that I can look at any moment in time. So that function will be P of t equals 72.2 e raised to the power of negative 0.0069t. Part B asks us to estimate the percent of adults who are married in 2019. Now, what are we trying to solve for? Percent of adults who are married, which means we need to define our variable. Since we're looking for the percent, we will say that is P of t equals the percent of married adults after t years. So we've defined what we're looking for. Now we have to find an equation. Well, that's where we use the part we generated in part A. Our equation is P of t equals 72.2 e raised to the power of negative 0.0069t. From our equation, we're ready to solve. But we have to kind of figure out, what is t? Well, it says in the year 2019. Does that mean that's what I plug in? No. Remember, it says it's been continually decreasing since 1960. 1960 is the beginning year. Well, if we're looking in the year 2019, we need to find the difference. From 2019 to 1960, how many years have passed? Well, that would be 59, which means T will now be replaced with a 59. Now that we have it in writing, now you may pick up your calculator. Hopefully you found the result to be 48.05470483. Now it says estimate the percent. We are going to round to the nearest percent or nearest whole number, and that would be the 8 is in the ones place. We look immediately to the right, and because we have a 0, it will not round up. So we estimate it to be at 48%. Now that we've solved it, let's write our sentence. In 2019, approximately 48% of adults are married.